What do you think is easier, using the quotient rule or using the product rule to find the derivative of a function? Well, what if I told you that whichever one you liked better, you generally could manipulate the problem so that you can use the one that you like? I know it sounds kind of crazy, but you might be surprised that this method is pretty easily applicable to find the derivative of a lot of different types of functions. So today I'm going to show you exactly how you can do this so that you can turn just about any quotient rule problem into a product rule problem, or vice versa, so that you can use whichever one you're more comfortable with and maybe even get practice with both along the way and become better at both of them. So without further ado, let's go ahead and jump into the example and I'll show you exactly what I'm talking about. So here we have this function, y equals 15x minus e to the x all over x. And what I want to show you is that we can actually use a few different methods to find the derivative of this function. In fact, there are probably several other ways that we could do this. I'm going to show you two specifically in this video. And the point I want to prove here is in math, or in calculus especially, but in math in general, there's usually multiple ways to solve any given problem. So the point that I want to show here is that when you're looking at a problem, if you're not sure how to solve it, you should generally, it's a good idea to just take your best guess and go with it and see what happens, because you may be thinking that a certain way is going to be the right way, or that there's maybe a wrong way that you could go about a problem. But what you'll oftentimes find in calculus is that there's multiple paths that get you to the correct answer. So even if you do it a way that maybe the creator of the problem or the grader of the test didn't expect you to do it, if they don't specifically tell you to do it a specific way and you do it a different way and get to the right answer, you still got the right answer. So I really want you to kind of keep that in mind, and I wanted to show you this example as kind of proof of that idea, or that ideology that you can keep in your mind as you work through math. So we have this function, and what we're going to do is find its derivative. Looking at it right off the bat, it seems pretty obvious that we can do this using the quotient rule. So one way we're going to do this is we're going to find the derivative of this function using the quotient rule. So the quotient rule says that if we have some function that is the high over the low, or a fraction where you have the numerator over the denominator, we can find the derivative of this function, this fractional function as a whole, by doing low d high minus high d low all over the low squared, which is really just a way to say we're going to do the bottom, the low of our fraction, times the derivative of the high, the derivative of the top, and then we're going to do minus the top, or the high, of our fraction, times the derivative of the low part, the derivative of the bottom, the denominator, and all that is going to be over the low part of our fraction squared, or the denominator squared. So to apply this, all we have to do really is figure out our high, our low, the derivative of our high, or d high, and the derivative of our low, or d low. High and low are usually going to be easiest to figure out. The high is just the numerator, so 15x minus e to the x. And the low is just the bottom, just x. D high is just the derivative of our high, the derivative of our numerator. Derivative of 15x is 15, minus the derivative of e to the x is just e to the x. And then d low is just going to be the derivative of our low, or the derivative of our denominator. The derivative of x is just 1. So now we can take those four pieces, basically plug it into this formula, and see what we get for our derivative. So we're going to get y prime equals low d high, so x times 15 minus e to the x, minus high d low, which is 15x minus e to the x times 1. And make sure to put this in parentheses because this minus needs to distribute. So we're going to get 15x minus e to the x, and then times 1, which isn't really going to do much. And then all that is going to be over the bottom squared, so x squared. And then we could definitely simplify this a bit as well. There's not going to be too much we could do to simplify it, but should be able to just kind of expand this out a little bit. So doing that is just going to give us, and we'll go ahead and just leave it in this form for now. So like I said, now what we're going to do is we're going to find the derivative of this function using the product rule. But you're probably looking at this and thinking, we have a fraction. How can we possibly do product rule when we have a function that is a quotient, not a product? Well, what we can do is we can actually manipulate this function and put it in a form where we can use the product rule. So what I mean by that is having all this stuff divided by x is the same as doing all this stuff times the reciprocal of x, or the reciprocal of x is just 1 over x. So instead of writing it like that, we can write 1 over x times 15x minus e to the x. And when you're taking derivatives of something like 1 over x, usually the easiest way to do that is to rewrite it in a form that's a little bit easier to take the derivative of. So what I mean by that is we could do x to the negative 1 times 15x minus e to the x. So now we do have a product. We have this thing here times this thing here. So now we can actually use product rule. Well, product rule just says if we have the derivative of f times g, one thing times another thing, the derivative of that product is just going to be the derivative of the first times the second plus the first times the derivative of the second. So similar to what we did over here for quotient rule, for product rule, we kind of want to figure out what f and g and f prime and g prime are first. So it doesn't really matter which one we call f and which one we call g. Let's just go ahead and say that f is x to the negative 1 and g is 15x minus e to the x. The derivative of x to the negative 1 we can just take using the power rule. So we're going to bring the power down in front and lower our power by 1. So bring the negative 1 down in front, lowering our power by 1, doing negative 1 minus 1 is going to give us minus 2. And then the derivative over here, we're going to get 15 minus e to the x, because the derivative of e to the x is just e to the x. So now we're going to cross multiply these. So we're going to do f prime times g, g prime times f, and then add them together. So we'll start here. We got y prime being negative x to the negative 2 times 15x minus e to the x, and then plus x to the negative 1 times 15 minus e to the x. And now what we'll want to do is go ahead and kind of simplify this into a form that matches this. You may be already able to see from here that these are going to be equivalent, but we can actually make it a little more obvious here, because having x to the negative 2 is the same as having all this over x squared. So this is really the same as we have this negative sign that's going to distribute in there. We're going to get negative 15x plus e to the x all over x squared. And then over here, we're going to have 15 minus e to the x all over x. Now, in order to combine these two fractions together, we would need a like denominator. So we can multiply this fraction by x over x, and doing that is going to give us negative 15x plus e to the x over here. And then this, obviously, we're going to get x times x on the denominator, which is again x squared. And on the numerator here, we're going to get plus 15x minus x e to the x, which you can see is exactly what we got from doing the quotient rule over here. We have a minus 15x right here and here, plus e to the x, plus 15x minus x e to the x, all over x squared. So you can see we got the exact same derivative by using the quotient rule as we did by using the product rule. All we had to do was manipulate our original function to be in a form that was applicable for either quotient rule or product rule, depending on which one you would rather use. So it really is just kind of up to personal preference of whether you think the quotient rule is easier or the product rule is easier. And oftentimes you can get it into a form where you can use whichever one you like. So that should help make both product and quotient rule problems easier for you when you kind of have the option to use one versus the other. So hopefully now you have the tools to do most quotient and product rule problems the way you like to do, so that you can get the answer right and feel more comfortable while you do it. But just remember, don't feel afraid to experiment when you're trying to solve problems that you don't know how to do. That's the best way to learn math and calculus specifically, is to try out different things and see what works. So if you found this video helpful, please be sure to hit that like button down below and subscribe and hit that bell icon as well so you're notified of all my new videos. If you want to keep learning about derivatives, I have made a few other videos. Go ahead and click on one of those, and we'll see you next time. Thanks.